So welcome to the channel, guys. I hope you all are fine, doing great. Today we are going to discuss this GFG problem of the day, handshakes. So moving to the problem, this is the problem. What we are given? We are given n persons that are sitting on a circular table, or we can say round table, and any person can do handshake with any person. Like a person X can handshake with any person Y. Uh, okay, and if our circular presentation of our n persons is like this, then 2 and 3 cannot handshake and 1 and 4 cannot handshake because it will produce a cross. Okay, so suppose if like here, if 1 4 2 3 will do handshake, I'm using some other color, will do handshake, then these 3 and these 2 remain unhandshake because they cannot shake hand with anyone, because now they cannot shake hand like this. Okay, because if they shake hand, then it will cross 1 and 4. That's why in this case we can only shake either 1 and 4 or 2 and 3. So our two of the number will remain unhandshake in each case. That's why we are saying 2 and 4 and 1 and 4 will cause cross. Okay, so what we are doing, we have to make we have to count all the way, so that all the n persons can handshake, but they don't cross each other. So what we are doing, like for 2, answer is simply 1, and for 4, what can be the answer? uh, 1 can be do it with 3, 2 can do it for 4, and the other ways can be like 1 do it with 2 and 3 do it with 4. Okay, like if you are supposed to, 1 cannot do it with 4, then 1 can do it, but as like 4 should be its next adjacent number. Okay, here 3, here 2. In this case also it can do like this, or either this case. So in this case also, now 1 cannot shake hand with 3. So in each presentation of n is equal to 4, we can maximum shake hand by total 2 ways. Okay, so now what we have to do, we are given the time complexity to trace to the power n, but we had solved it in n square only, and constraint are 1 to 30. Okay, so moving on to the problem. So first of all, I want to explain you some method. Handshake, like if there are two persons, then they can just handshake with one way. Okay, if there are 4 person, 1 2 4, then they can handshake by 2 ways. I explained you earlier. Okay, and as you can see here, it is written that n is always even. N is always even. Here where, yes, n would be even also, you can see here n would be always even. So when there are 6 person, like 1 2 3, I'm taking this here, 1 2 3 4 5 6, then how many ways one can shake hand with 2 3 4 5 6? We are independent, we fix one. Okay, what we are doing, we are fixing this one at my initial position. Okay, and I will rotate my all these persons accordingly. But in when I am explaining you for n is equal to 4, I told you whether any representation of n person you are doing, you will always get the same answer. Like when you are doing it like this, you will get an answer 2, but when this is answer, and when you are doing it is like this, you will get answer 2. Okay, or whether you are doing it like this, 3 4 2, you will get answer is equal to 2 in this case also. So okay, so this is always same. I just use it because I wrote down 6. So okay, so what I mean for each representation we will go to the same answer. Okay, the same number of ways. Okay, so now, so what we can do, first of all, we will make the handshake of 1 and 4. Then we are remaining choose some other number, and we are remaining with this four number. And for these four number, how many ways we have handshake? We can do handshake total two. Okay, yes, you understand it. When we have four members and we fix one and two, then we have total number of ways is equal to 2. Okay, because this is fixed. So, and for this we have two numbers. Okay, but now sorry, now move above and take another presentation. 1 2 3 4 5 6. Now fix 1 and 3. Can it be possible? No, it cannot be possible. I am telling you why. Because now if you are doing it like this, then these three will become separate and these two will become separate. I mean the number on left side of it will separate down from the number on, and I mean left and right number will become separate, so they cannot do handshake. And here as you can see, odd number of number are left, so so single number in each of the direction will is left out, that cannot do handshake. So this case 1 and 3 cannot be possible. Okay, it cannot be possible. Now I will do next case. 1 2 3 4 5 and 6. Okay, now try to do with 1 and 4. Can possible? Yes. Now we can do handshake of 2 and 3. Sorry, now we can do handshake with 6 and 5. So here the number of ways we can do handshake with the 2 and 3 is equal to 1. Number of ways 5 and 6 can do handshake is equal to 1, and this is fixed. So total ways are 1 into 1 is equal to 1. So when 1 and 4 are joined together do handshake, then total ways we have is equal to 1. Okay, now when 1 and 5 are doing handshake, I am telling you because this is very simple approach of thinking it. We are dividing the number and in each way we are getting same answer. That's why it became very easy to understand. 1 and 5, it not possible. Odd number of elements, so one element left out from each position which not doing handshake, so this method cannot possible. Now the the last one is left out. What is the 1 and 6? If 1 and 6 are committed, then again these four number are left out. And how many ways this four number can do handshake is 2. Okay, how why it is equal to 2, I am explaining you. If you just curious of knowing, same color I took. Yes, it is like 5 and 4 can do handshake, 2 and 3 can do handshake, and other one is 5 and 2 can do handshake, and 4 and 3 can do handshake. Okay, here the only one case that cannot be handshake is 5 and 3. This way is not possible. Okay, I am explaining you earlier why. Okay, so total two method possible here. So the total number of methods we got is equal to, when 1 and 2 answer is equal to 2. 3 with 3 it is not possible, so answer till here is equal to 2. When 1 and 4 we can get one way more, so 1 plus 2 is equal to our earlier answer, so our updated answer is 3 now. With 5 it is not possible, so our answer is equal to 3. With 6 it is we get two more ways, so our initial answer is equal to 3, we update is with 2, so total ways is 5. So 5 should be our answer. I am checking whether 5 is our answer. Yes, sorry, for n is equal to 6 we have to check out. For n is equal to 4, answer is equal to 2. Okay, I don't know why, but this is created. I'm refresh the page and doing it now. Submit it. So the answer. I don't know why it is causing the problem. Yes, you can see for 6 answer is equal to 5. Okay, so now let's move on to the approach. Now what we do, we will take our dp of n plus 1, because we have to store till n, so we are taking n plus 1 side. We initialize dp with 0 and 1 is equal to 1, because when our number is equal to 0 number, else we don't require to initialize 1, because we are never left out with the odd number of element, so we just can initialize dp0. Okay, so with 0 number of element we initialize it with 1. I am explaining you why. And dp2, because for dp is, for when n is equal to 2 we have only one ways, and we are starting with I is equal to 4. We run the loop till our I is less than is equal to n, and we add up 2, because as we can see n will always be a even number. Then I will make count for j to I. Why j to I? Because you can see one by one I try to make it with 2, and as you can see I cannot make it with 3. Okay, so for odd number we cannot make it, because with 5 also I cannot make a way. Okay, with 4 then, and with 6. So okay, so I will check for each number for 2 less than is equal to I, and I will add plus 2 every time. Okay, then I will take two number a and b. What is my a store? A will store my left out number, sorry, a will store my left out number, like this is the count of my a, this is my j. So j minus 2 I am doing for a, sorry, j minus 2 is equal to, j is equal to 4 here, j is equal to 4 here, you can see. So j minus 2 is equal to 2, so 2 number I left out with, or you can see we have total j number here, we remove this one and this one, so j minus 2. Okay, so our a will represent number from I 2 to j minus 1. Okay, this is my j minus 2. And what is my b represent? B will represent my this side number from the left side of my 4. Okay, how can I calculate it? My I is equal to I minus j. Yes, you can see here my b will represent this number. How can I calculate it? My I is equal to 6 here, as you can see my I is equal to 6, so I will minus 4 among it. I will minus is equal to, it is equal to 2, so these are two number left. So this is 6 is my I basically. So this 6 is my I, and so I will subtract my there, so it will give me answer is equal to 2. Okay, then I will check if my both of this is greater than or is equal to 0, then I will add the multiplication of both. Why? Because suppose the this number can be represented in x way. I change the color. This number can be represented in x way, this in y way, so total ways can be x into y, xy. Okay, x into y, it is sign of multiplication. So okay, and then at last I will just return dpn. So yes, as you can see all the test case pass out, so I think it's clear now. So I hope you guys like it. If you like it, then please subscribe the channel and like the video. Thank you for watching this, guys.